tonight?
I have a couple of problems from my homework
Okay.
that I had trouble with. Let's see. Okay, page.
This audio we have seems to be a pretty good connection, but let me know if it gets choppy or something. I do have a different way of doing it that seems to work.
Okay.
I have a couple other students that occasionally the audio doesn't work real well.
Okay. Alright, it says evaluate the indicated function for f of x equals x squared plus 1. And g of x equals x minus 4.
Okay.
And then it's f over g in parentheses, then -1 in parentheses.
Okay, so they want to know what f of x divided by g of x is. And then they want to know what f of 1 is.
No, it's just right beside it. There's a
Probably
-1.
it's probably f of g of x is what you're looking for.
Okay.
That's what you call f of g of x. Or fog sometimes. But, okay, how would we evaluate it if I said, what is f of 1?
You would just plug 1 into all the x's.
Okay. If I said, what is f of x squared?
You would put x squared into all the x's.
Not into all of them, just into this one right here. So what would f of x squared equal?
X to the 4th plus 1.
Okay. So now we're doing, instead of x squared, we're going to put in g of x, but g of x is x minus 4. So it's really the same as saying, what is f of x minus 4?
Okay.
So what is f of x minus 4?
X minus 4 squared plus 1. That would be
Expand
x
that.
squared minus 8x. X squared minus 8x plus 16, or plus 17.
Okay, and that's the final answer as to what is f of g of x. Okay, they probably also want to know what g of f of x is. In other words, these are called composite functions. You could look at it, go ahead.
So it would be x squared plus 1 minus 4.
Yes. In other words, that's the same as g of x squared plus 1, which is the same as plugging that in for x. So there's g of f of x, and the other one was f of g of x.
Yeah.
Have you had inverses yet?
Could you give me an example?
Yeah. An inverse function, if f of x is equal to x squared and g of x is equal to the square root of x, is one the inverse of the other?
Yes.
And the definition of if something is the inverse, then fog has to be equal to x and goth has to be equal to x.
Okay.
Fog would be f of g of x, which would be f of square root of x, which would be square root of x squared, which does equal x. So fog is equal to x, and goff, well, that would be g of x squared, which would be the square root of x squared, which would also be equal to x. So as long as fog and goff are equal to x, then g of x is the inverse of f of x. And it has to fit that definition. Two things cannot be an inverse of one another if this isn't true. Both of these have to be true.
Right. And I might need to send this problem to you.
Okay.
It's complicated.
Take a quick picture of it and let me open up my email, which I leave closed because it kind of slows everything down. Is this a problem with graphing?
No.
Or is it
another
just
one
hard
of
to
these.
verbalize? Okay.
Yeah, it's hard to verbalize. What's your email?
Probably, once you do it once, it should recognize it the next time you try to send it. So you don't have to type it out each time.
Mm-hmm.
There it is. Let me know when you've sent it.
I just did.
Okay. It usually takes 10 or 15 seconds before I get it. It's slower than texting, I know that.
Mm-hmm.
Sure you sent it to that? That's davidcowan1949 at gmail.com.
Yeah.
Yeah, there it is. Sorry, didn't mean to question you.
That's fine. And it's number 23.
Nice camera. Must have an iPhone. Yeah? Or no?
Yeah, I do.
Yeah. I've got a 5 megapixel and it doesn't quite take it in this good a resolution.
Mm-hmm.
Hold on. I'm trying to get set up here. What the heck? All right. 23. F divided by G, I presume that's what they want, multiplied by minus 1 minus G of 3. Okay, let's divide F by G. You know how to do long division with polynomials?
Yes.
It's not that easy. You have to make sure you put dummy markers in there, like that. I'm going to divide by x minus 4. So what goes here?
X.
Okay, and then what's the next step?
Then you multiply x minus 4 by that, and then subtract it from x squared plus 0x plus 1.
So what's this?
It's going to be negative 4x.
Actually positive 4x. Remember, we're subtracting this.
Oh, right, yeah.
So it's 0x minus a minus. So that becomes 4x. Bring down the 1.
Mm-hmm.
Goes in there 4 times. 4x minus 16, subtract 1 minus a minus 16, you get a remainder of 17 over x minus 4.
Mm-hmm.
So, f over g is this. X plus 4 with a remainder of 17 divided by x plus 4.
Mm-hmm.
Okay? I want to multiply that by minus 1.
Okay.
So, I'm going to multiply minus 1 by every term there. Because it's really x plus 4 plus that remainder.
Mm-hmm.
So it becomes minus x minus 4 minus this remainder. And now we're going to subtract from that g of 3. And what is g of 3?
Negative 1.
So we're subtracting a negative 1, which is the same as adding 1. So what do we got here? We got minus x minus 3 minus 17 over x minus 4. I presume that's the answer they're looking for. Do you have an answer key on any of these?
Yeah, let me check.
Go ahead and check. I'm curious because this one's kind of it's strange that they would have that remainder, but they wouldn't make it evenly divisible.
The answer is 3/5.
Ah, I see what's going on. I've never seen this kind of notation before. This doesn't mean f divided by g multiplied by minus 1. It means f divided by g evaluated at minus 1.
Oh.
So, in other words, when we got this part here, which was all positives, I need to evaluate that at minus 1, not multiply it by minus 1. I didn't realize that's what they meant here. So if I plug in minus 1 for x, what do I get? I get 3 minus 17 over 5 plus 1. Whoops, no, yeah, plus 1 for the g of 3. So I get 4 minus 3 2/5, and that's equal to 3/5. Okay, my apologies. I didn't realize what this notation meant. I truly have never seen that before. There's lots of ways to represent composite functions, and if you have 6 different books, you'll see 6 different ways. It's pretty good. Okay, but now we know what to do. The hard part of that was actually doing the division.
Yeah. So would it also work if you just kept the originals and you just put x squared plus 1 over x minus 4 and then plugged in negative 1 for that?
Let's try it. I'm not sure, to be honest with you. So if I plug in minus 1 for this, I get 2. And if I plug in minus 1 for this, I get minus 5. Yeah, and then plus 1, that gives you 3/5. That's a much easier way of doing it. Don't have to do the long division that way. Okay, that's worth knowing. So this expression is the same as f of 1 divided by g of f of negative 1 divided by g of negative 1. Correct? Yeah, that right there. Oh, that's much easier. That way, yeah, doing that, it eliminates the hard part of that problem.
Yeah. So just for practice, we do 24.
Sure. So this is f of 5 times g of 5 plus f of 4.
So you just plug in 5 for x squared plus 1, then x minus 4.
So f of 5 is what?
So it would be f of 5 is 26.
Times g of 5?
1.
Plus f of 4.
17.
43 should be the answer.
Okay.
Was it?
All right.
Do you have the answer? You just have the odd answers?
Yeah.
Okay. Well, let's do 21 for practice, just because.
All right. So it's going to be f of 5 over g of 5. And then it's going to be 26 over 1.
Uh-huh.
So just 26.
Yeah.
And yeah, that's right.
Okay. So it must mean the same thing here. Now, so I guess this is the same notation. In other words, this is going to be f of 3t minus g of 3t. Let's do 17, because we're going to end up with a variable as an answer. That's good. So f of 3t minus g of 3t. What's f of 3t?
It's going to be 3t squared plus 1, which is 9t squared plus 1.
And what's g of 3t?
Minus 3t minus 4.
Very careful about that parentheses. If you happen to omit that parentheses, you're going to get the wrong sign on that number.
Yeah.
So it's very important when you're subtracting something and you're substituting a binomial or a trinomial term for it, always use the parentheses. In fact, I would always use them just to be safe. You can never overuse parentheses, but you can underuse them. So this becomes 9t squared. What's the rest of it?
Minus 3t plus 5.
Okay. All right. You want to look at some of these below 25 and stuff? Or?
Yeah, I actually had a question on 27.
Okay.
Graph functions. Okay.
Graph the functions f, g, and f plus g, I presume?
Mm-hmm.
Okay.
Yeah.
Hold on, let me make some room here. (27) f of x equals x squared. What does that graph like? What does that look like?
It's just a regular, it's just a parabola.
It's a parabola with its vertex at the origin.
Yeah.
Okay. And g of x equals minus 2x. What's that look like?
It's a straight line going downwards with a slope of -2.
Okay, so it goes through the origin. The y-intercept is 0. Slope of -2 is steeper than a slope of -1.
Yeah.
And it's negative, so it's got to go from upper left to lower right. So I guess we did what they, oh no, f, g, and f plus g.
Yeah, that's the part I got confused on.
Okay. Well, You just add them together.
But I'm not really sure how to graph that.
Well, let's start on the left side because that's easier. If I want to know what point is at -1, and I'm adding them together, I'm going to add this value plus that value. So, there, maybe?
Oh, okay.
So that's my new f plus g. I guess. Do you have answers on these? Do you have graphs of these to show you?
Yeah.
Okay. At the origin, it's going to go through the origin. On the right side of the axis, notice that we're adding a negative to a positive. So the point looks like it might be right there. And then over here, this goes up faster than that goes down. Maybe. Well, I'm going to say that graph looks something like that.
Okay.
Does that look right?
Yes.
Okay. Have you had any trig yet?
I'm not sure.
Okay. Same thing as how to graph sine x plus x. If I had this function here. Well, I know how to graph sine x. That's like that. Well, and I know how to graph x. Y equal x is like that. So to graph the sum of them, you merely add them together and you end up getting something like that.
Okay. So if it's a graph like x squared plus 5x, you would just graph a 5x line and then an x squared line and
add them together. Yep. In other words, there's x squared, there's 5x. So add them two together, it's still 0 at the origin, but the moment you get up to about here, or say here, it's going to be way up high. Because if that value is 2, and that value is, say, 8, then adding them together is going to give you a value of 10.
So say it's like a x squared plus x plus 2 graph. Would you just graph a x squared and then a x plus 2?
And then I'd add 2 to that. In other words, that value would be, instead of 10, it would be 12. If it was x squared plus x, plus 8x plus 2. Okay, we got about 5 minutes left.
Okay.
Anything you want to go over in that 5 minutes?
We could just do small practice like 26.
26?
That's really all it. Yeah.
Okay. 1/3 x. It's got that kind of a slope. Flat. And minus x plus 4 goes through this point. Has a 45-degree slope like that. Now, there must be an easier way to graph these. In other words, can't I just add these two functions and graph the result? I think we can.
Yeah.
So if I add f of x and g of x, I get 1/3 x minus x plus 4, which is minus 2/3 x plus 4. So this really is what we want to graph. Enough with the nonsense of adding this value to this value to get some value up here that we'd be guessing at. let's go ahead and algebraically add them. And then we would graph minus 2/3 x plus 4. Still goes through this point, which it should, because when I added that and that, I get that. And it has a slope of minus 2/3. So the graph of f plus g would look something like that. And that actually does look like the halfway point. In other words, by doing it the other way, if I took this point and added this negative value, I would get that value right there. If I took this point and added this negative value, I would get that value right there. So it looks like the way to do this is just to add the two functions and then graph the result.
All right. That's it for me.
All right. It's a good place to end.
No problems.
Yeah. Okay, yeah, you know, whenever you need a half-hour session, text me, because I almost always can fit a half-hour session into a day.
Okay.
Just because I end up with a lot of half-hour breaks. And in fact, on my website now, I've actually incorporated the half-hour session in there. If you go online, you can schedule a half-hour session. And it'll show you all of the 30-minute windows that are available. Might be
I checked
easier.
that, but it didn't give anything.
Oh, it didn't give anything? It may have been because I have so many appointments on this. Oh, I had it blocked out. That's what the thing was. Whenever I have like 4 appointments in 5 hours, I usually block out the other one just to give myself a rest. But don't let that discourage you. I never mind filling in, you know, removing that block for somebody that needs a half-hour session. That's absolutely fine with me.
Okay.
Okay? So always feel free to text me and ask if you don't see it available. All right, Griffin. Talk to you next time. Bye-bye.
Thank you.
You're welcome.
All right.